know if it works. That doesn't. Oh, it's like from yeah, it's funny. We can see something that isn't.
Is it just a delay or?
I don't know. Yeah, it was. Now it works. Yeah. Yeah. Oh, actually, I can come up and like.
Yeah. So we're having the first thing here. Yeah. This works. And you can come to.
Oh yeah, it works.
We have 3 mics.
Okay, hello everyone. It's nice to see you here today.
We have.
Hope that there is. There is still some pizza, so be liberal and take some. And there is also some drinks in the fridge, so they are free to take as well. First, I would like to thank everybody for coming here on my behalf. I'm from Emblica and I will be presenting something later on. But first, I will give a little speech for Lucas and Anni, and then we will finally release Lucas on his own here. But thank you for coming. There is also live stream, and the link is in the Meetup group. So if you have some friends that couldn't get it here, couldn't make it here, so you can share it. And well, I think that will be some kind of way to virtually come here, but you can't drink the beer though. Okay, well, go on.
Hello everyone, from my behalf as well, and very much welcome. Thanks for coming. It's the holiday week in this part of the world and whatnot, so awesome that you came. So I'm Annie, I'm one of the organizers as well. If you have anything to tweet to us, any opinions, comments, just want to say awesome work. I think it's Kubernetes Fin. So tweet there and I'll probably catch it and like it and retweet it and whatnot. And yeah, Lucas.
Okay. So, well, you've had some food already. And as Teemu said, just take more if you want to. Now follows a presentation from myself on what has happened during the latest, since the latest meetup, and things like that. And then from Carl here, and a presentation from Teemu. After that, we'll have an hour or so to just socialize and talk about whatever that interests us. And yeah, then a big thank you to all the people that made this happen. Maria offered so that we could have this place. The pizza is brought to you by UpCloud. Emblica bought the drinks. And then CNCF, this is also an official CNCF meetup, so we're sponsored by them as well. So, yeah, I think that's it, and we can start.
Yeah, let's release Lucas. Give some applause for Lucas. So he will
Okay, so we have a lot of exciting news since last time, and I'm gonna highlight them here. First, if you don't know me already, I'm Lucas Kjellström from Middle Finland. I speak Swedish. I'm attending Lukio or Gymnasium right now. I'm also an abiturient, as you see here. We just had Penkis, which was a lot of fun. And then I'm the CNCF Ambassador, Certified Kubernetes Administrator, and leading a SIG, Special Interest Group of Kubernetes. And yeah, I've been doing Kubernetes stuff for 2, maybe soon 3 years, and driving my own company that performs contracting. So yeah, and if you're coming to Copenhagen, I'm gonna have a talk there as well. I really hope you do, because it's a really fun event, KubeCon, and you can do a lot of other stuff as well. So, what happened in Austin at KubeCon and CloudNativeCon North America? Well, and by the way, here up here, bit.ly/KatesFin February intro. You can see this same presentation and click all the links. This material is meant to be to serve as a reference, so you can use this, go to follow all the links, and then
available in the meetup?
I don't. It might be, and it could fix it if not. Yeah, you could just post this. Yeah, there as well. Yeah, cool. And of course, if you have any questions or whatever, we have a mic here and we can just send it. I'm happy to answer directly. Okay, so all the sessions are uploaded to YouTube. So this is a great chance to see, even though you couldn't make it to the event, you can take, you can see all the amazing presentations and keynotes there were, and learn from that. KubeCon is now going to be organized in Asia as well in November. So now we have Copenhagen in May, we have Asia or Shanghai in November, and then it's going back to Seattle in December. So 3 times a year is a nice number. Also, a Kubernetes mentoring program has started, which a couple of people are piloting. I'm one of the pilot mentors, and we're testing this thing out and trying to get it working to then release it at a larger scale. So we're doing the beta now, and hopefully later this year we'll enroll it on a larger scale when we have more experience. And what makes CNCF and these events so great is the diversity of the people there. So we had this time we had 103 diversity scholarships to the event, and thanks to these 4 girls in the diversity scholarships committee, they did great work, and 250K was used just to get people from underrepresented groups to this event. Also, we had a lot of major releases. CRDs, FluentD, Jaeger, and Containerd all hit 1.0. And again, you can follow these links and see what it's more detailedly, what it's about. And as I said, here we have KubeCon Europe and China and North America at these dates. I highly recommend you to go there and see what it's all about. You'll meet awesome people. Then we had during KubeCon, CNCF have some community awards. So one is Top Cloud Native Committer of the Year, which this time was given to Clayton Coleman, lead architect at Red Hat. And Top Cloud Native Ambassadors were given to Sarah Novotny and myself, which was nice to see. But also they wanted to highlight that there are a lot of people in this community who do a lot of work, but work that isn't visible, maybe in that sense, or they may necessarily not get the most credit because they do work that has to be done, but it's not really fun all times. So therefore, they made an award called Chop Wood and Carry Water, which is language used by, for example, Sarah to describe this type of work. And this was given to Dan Gillespie, Don Chen, Jay Singer-Dumas, Anthony Yen, Brandon Phillips, and Julius Volz. Also, as you might have seen, CNCF rolled out a certification program for Kubernetes in the latest months. And since there's a lot of vendors that offer hosted Kubernetes solutions. There's a lot of projects, open source, that set up Kubernetes for you. You don't really know, like, okay, so if I like deploy my application here on this cluster, does it still work on this cluster that we have here? Because they might have configured Kubernetes in different ways or whatever. So therefore, it's really important to have some kind of standardized testing, and the community does this with end-to-end tests. And Kubernetes has a lot of end-to-end tests, but still too few. But and some of them are marked conformance. And in order to be a certified Kubernetes distribution, you have to pass this conformance test suite. And if you do, you can upload your results, basically the output of a tool called Hepti or Sonoboy, which you deploy to your cluster, and it will E2E test it and check that everything's working. If this output is good, you can upload it to GitHub, to github.com/katesconformance, and then you will be an officially conformant Kubernetes distribution. And there were a lot of, well, people that did this. And now where the community is also looking into making profiles and more specialized, like this kind of thing works here with these add-ons, this thing doesn't work on this environment, and vice versa. And as an end user, you can also run these end-to-end tests yourself. It's basically just a kubectl apply command. And well, here we have a couple of companies that decided that this was a good thing and certified themselves so that everyone can see that if you deploy your application on some of these companies' Kubernetes distributions, you can then move them. You can at least expect some kind of a basic set, minimum set of functionality across all places. And also, they have, so that is one of the new things. The other thing is, the other announcement is that we have a certified Kubernetes administrator program, which has been, it was existent at this, maybe at the last time as well, but now it has been rolled out to a larger scale. We have first this curriculum and Kubernetes fundamentals course from Linux Foundation, which you can take if you want, or if you feel that you know Kubernetes very well, you can just take the exam, which is also at $300. In complementary to this, CNCF provides a free EDX course, which is a basic introduction to Kubernetes. From there, you can also buy a completed certification mark for €100. And over 16,000 people have registered and taken this exam already. And if you're a company and have three certified Kubernetes administrators, you can enroll for the Kubernetes Certified Service Provider program. And here we have a couple of companies as well that have at least 3 certified Kubernetes administrators, probably more, some of them. And so that was more on the CNCF Kubernetes CNCF side. Here we have Kubernetes 1.9 as well. That was released in December. Again, we have often when Kubernetes is released, we have this thing called 5 days of Kubernetes and the new version. So we have first the announcement, And then we have 5 blog posts related to this release that highlights the major features and what has changed and what has gotten better. What a shout out here is the Workloads API, which hosts important things like daemon set, the resource in Kubernetes that makes you run a pod on every node, or deployments, which is the fundamental object of Kubernetes that lets you specify, I want 3 replicas of this template, or stateful sets, which makes it easier to run stateful workloads inside of Kubernetes by providing some different rules, and so forth. So this was a huge win, because now you know that you can use this version 1 API, and it will be the same for a long time. Windows Server support was merged as alpha a year ago. Now it's graduated to beta. So you can basically run Kubernetes on top of Windows and also run Windows containers on these machines. Then we're coming to the extension points of Kubernetes, but some extension points were also graduated to beta. And then we have a cool new feature called container storage interface. We already have a couple of other interfaces like container network interface, container runtime interface, and now we have container storage interface. And yeah, I'll get to that in a minute. So this is what Kubernetes basically looks like, and the architecture. And I have a presentation. If you click this link, I have another presentation that details this a bit more. But yeah, on a high level, as you might know, we have an API server which you talk to. No matter if you're a pod or a user or whatever controller in the cluster, you always go through the API server, which then stores, which is stateless, and stores the data inside of the database etcd. Then we have the controller manager that implements the Kubernetes business logic and makes sure that everything, the decide state, is the actual state. So the admin sets the decide state, and then the controller manager reconciles all the time to make this the actual state. And then scheduler, when you have new pods in your cluster, it's going to bind this pod to a specific node. You can extend this as well, as we'll see. Then we have the networking layer, which is container, which implements container network interface. And we have a container runtime interface that could be Docker, or it could be CRIO, or it could be containerd, or it could be whatever other implementation you might like. So one of the nice things about Kubernetes 1.9 is also that the community wrote some new docs to how to extend Kubernetes. Teemu will get more detail on this later, on at least one of these. But generally, there's a lot of extension points in Kubernetes, because at the same time, it's an advanced system. And here you have the links to the different parts. And it's why I showed this is because it should be mentioned that Kubernetes itself might not be the like the layer you want to operate at the business level. You might want to have something on top of Kubernetes still that provides more value to your business workflow. So the great thing about Kubernetes is it makes writing these rules, writing these distributed systems becomes a lot more easier. When you're sitting on top of Kubernetes, you can do basically anything and write your own like platform or whatever that these people also talk about. So you have plenty of options to extend Kubernetes to make it behave the way you want. So I showed the landscape last time. Now it has evolved even more and hit its first stable version. This is a project of CNCF to just show a little what projects there are in this sphere. And it's kind of overwhelming, right? There are so many projects. How can you know which one to use? Which ones are trusted? Which one can work well also in the longer term? And when you have like 50 options to choose from, which one is good for your workflow? So it gets to a point where you want to trust something, but both on a like project level and a technical level. And that's why CNCF has this technical oversight committee, which looks at this landscape, and then these are top architects, and they look at this landscape and choose whether to bring in some trusted, high-quality project into CNCF. And they have added some new ones as well. On the certification, we have the Certified Kubernetes Administrator exam has been updated to 1.9 since last time. And there's also a new certification program that is upcoming, like in a couple of months, that is called Certified Kubernetes Application Developer this time. So we have both CKA and CKAD. This certification is more focused on how you build applications on top of Kubernetes versus how you manage Kubernetes and set it up and make sure it's working well. So there are two different scopes here. General availability of this exam certification is expected in the middle of this year. And yeah, so I was just talking about which projects CNCF hosts, and this is the current state, and we have four new ones since last time in October. So, for example, Notary and the update framework, and Vires and Rook, and you can read these proposals here to know more what it's about, why it should be in the CNCF, and why people think it's a good project. It's all on GitHub, so anyone can look it up, what people think. And one thing more. Now CNCF has split up its projects to distinguish incubating projects and inception projects. Inception projects are in a much earlier stage and might fail or might not, but it's from inception they can then graduate to incubation, and from incubation, like where Kubernetes is, they can graduate to be a real Kubernetes CNCF project. So the first project that is probably going to graduate is Kubernetes later this year to become a fully fledged member of CNCF. But there's this three-tiered process of becoming a member. But instead of the lowest stage, the inception phase, CNCF is now debating to rebrand it as a sandbox instead. Instead of having this inception stage, they would call it the sandbox. They haven't voted yet on whether to do this or not, but it's probably going to happen in 2 weeks or so. if the technical oversight committee decides to do so. Then we have a cool project that is called DevStats, which basically queries GitHub, aggregates all data on CNCF projects, and then shows them on a Grafana dashboard available online, so that the community can keep track of its own progress and see, like, for example, how long does it take for a pull request to be merged or reviewed, or for how long is the mean issue open, or stuff like that. So this is going to help contributor experience, to improve contributor experience across the board, for example. And for example, here is the view of Kubernetes. So we have GitHub stars, the definite metric of project success, right? And forks and open issues. So we see that issues has increased, but now it's starting to slow down, which is good because it can't ever increase. But stars and forks have increased a lot since the latest time. If you want to see more aggregated list of cool Kubernetes resources, there's this awesome Kubernetes project, which aggregates a lot of things in this ecosystem. You can now it's also in Gitbook format, so you can download it as a PDF or whatever. And if you find a cool project that is related to Kubernetes, you can also just submit a pull request, and there we go. Serverless computing. So CNCF has a couple of working groups. One of the working groups is the serverless working group. They have recently produced two major resources. One is a white paper on what serverless computing could be defined as, what it could be used for, what the benefits are, maybe the drawbacks, and a lot of this kind of analysis of different projects. And the other output is this landscape that you see. It's not as crowded as the full cloud native landscape quite yet, but we'll see. This is still in the 0.95 version, so it hasn't been graduated to 1.0 quite yet. So if you want to start using Kubernetes, here are some resources. You could do it right in your browser with Play with Kubernetes, or you could start it in your laptop with Minikube, or you could download KubeADM and from type basically apt-get install KubeADM after you've added the Kubernetes repos, and then KubeADM init, and boom, you have a cluster. Or if you, and you can install KubeADM anywhere on any machines you have. If you're liking AWS and have a lot of clusters there, or resources or credits, whatever, you could use COPS, which is a more high-level tool, which basically to which you can say, I want to have 3 masters and 10 workers, and it's gonna auto-scale with this the amount of workers with this pattern. Then you can do so as well and say that to COPS, and it's gonna create the AWS resources for you. Or you could create your Kubernetes cluster on Google Container Engine, which is a hosted service by Google. So that basically Google runs Kubernetes for you, and that's it. There are a lot of other companies that do this as well. As you saw, the 40 different providers. Many of them are having their own hosted solutions, like Azure, like now also AWS. It's gonna be public soon. here are two good ebooks to check out. The State of the Kubernetes Ecosystem, and the more recent one, Kubernetes Deployment and Security Patterns by the New Stack. These are excellent resources to use to get more insight into this ecosystem and what you might want to use Kubernetes for, and what Kubernetes maybe shouldn't be used for. I don't know. And also we have a couple of books. I have two of them with me today, just you might want to pass around. Kubernetes Up and Running, written by Kelsey Hightower, Brendan Burns, and Joe Beda. And Cloud Native Infrastructure from Justin Garrison and Chris Nova. And soon a new Kubernetes cookbook is coming out from Sebastian Gosguin and Mikael Hausenblas. Yeah, I highly recommend all these three. And also the Kubernetes cookbook when it's coming out in print format. And a last minute shout out to Kubernout, which is a community of like people that basically are interested in working towards the better for the CNCF and Kubernetes communities, and to share knowledge to others. For example, they have the Certified Kubernetes Administrator office hours, where you can go and like, how should I prepare for my exam? What are key things to keep in mind? Where can I find learning material? Things like that. And they have a Slack channel where they help each other. Also, the normal Kubernetes Slack channel is great and has over 31,000 users, which is, well, a huge sum. As said, you could go and take the free EDX, Introduction to Kubernetes course, or just follow along with the blog, or YouTube channel, or Twitter feed. Or you could be up to date by hanging out on the Kubernetes community meeting every Thursday on Zoom. If you want to know more about like what Kubernetes actually is and what it does, I haven't covered that yet. Then you might want to check the comprehensive overview of Kubernetes presentation by Bob Killenhout. I found that to be very good resource. Or also I have a bit similar presentation, Kubernetes Architecture Fundamentals, which is basically what I presented here, just one slide. Overall, you can go to CNCF presentations if you want more links to more material. And I hope to see you all in Copenhagen. And now we have a couple of minutes for feedback, if there is anything. So we want to know more from you about what kind of content you want to see. Well, obviously I have two more presentations, but anytime, please like say it directly to me, or ask for the mic or whatever. If you want to see specific things you want to see in this meetup. It's going to be like some kind of updates from time to time. This has happened since this time. And you might want to know this and this, which is not directly a technical or usage-oriented or end-user-oriented talk, but more this is probably worth knowing. So this is one kind of talk that's going to be happen from time to time, but also what kind of end-user talk do you want to have, or what kind of technical topics do you want to see. Thank you.
Okay, we're keeping a small break to fix the encoder and well, take more pizza and drinks.
check. Sound check.
Ei sun tarvitse näyttää tuota, mikä sun nyt on pyörimässä vai? Mä luulen, että se... Tällä rulluu. Okei, se on varmaan väärinpäin ja se tällä hetkellä siellä se... Vaihdan jossain kohtaa tuosta dupliketista. Pitäis kun vetää silleen, että mulla on vaan tää dupliketta. Joo. Joo, ääni korjattiin. Kuinka se vaiheessa menee tai se on niin kauan. Joo. Siinä on muutama minuutin viimeinen. Joo. Se on tuolla näkyy. Lähtikö se liveksi? Näin näyttää.
Okay, our streamer works again.
All right. I think we are ready for the second part of the show. Welcome everybody from my side as well. Thanks for the sponsors. Pizza Hut is my favorite. Ask anybody who's there at lunch. Best value to stomach ache you can get. Awesome. So my name is Karl Otz. I'm here to talk about containers in Microsoft Azure. Interesting. A couple of words about myself. I do not have a container orchestrator background. I am not a contributor. I think the only thing I've contributed to open source is a couple of maybe typos in the documentation, and I have once tried to push through a very small project internally from a small project in a large organization, and went through all of the pain and legalese that it indulged, and my golly, oh no, never again. But during free time, that's all for me. So during daytime, I am actually a cloud and cybersecurity consultant at Composure, and I run the Azure user group here in Finland, and I also organize the IGLUConf Azure conference. And I occasionally host a podcast called Cloud Gossip. I talk about, for example, containers in there. So my point of view is really as an outsider coming from the Azure and seeing what is this Kubernetes doing here in my Azure cloud and what can I do about it. With that, quick agenda. This is very open for Q&A, so please stop me. Please ask questions. If I don't notice you, try again. After that, it's either I intentionally don't notice you or then try again. And I'll do really brief history, then briefly about overall containers in Azure, and then Kubernetes in Azure, and hopefully even time for some demos, and let's see how those go. So this is typically where we started. So what is this Microsoft Cloud and what is this open source thing doing here? And well, this hasn't been the story this hasn't been the truth for a while now. Luckily, after at least one CEO change a couple of years ago, when Satya came as a CEO for Microsoft, everything started to slowly change to the outside world as well. I was happy to notice that we had the same artist for some of our, not for this, but the Gophers on my first slide as Lucas. The mother of Gophers who builds them, Ashley McNamara, is actually one of the many cloud advocates that has joined Microsoft in the recent years, together with, for example, of course, Brendan Burns. So the world is really different here. I have a couple of those noted here. As I mentioned, Brendan Burns, the co-founder of Kubernetes, joining Microsoft a couple of years ago, and then just recently Gabe Monroy together with the Days team. And they're actually made a huge push towards open sourcing a lot of the providers, a lot of the tooling that Microsoft is doing themselves relate to Kubernetes as well, not just building the platform for building platforms, but the tooling and platform for building those platforms as well. So it's really interesting to see this kind of change in this company. So containers in Azure. There is several different container services inside Azure. the naming confusion is not just a CNCF issue. At Microsoft, there is a lot of confusion related to those. The easiest one to get started is really the Azure Container Instance. That's basically containers as a service, not to be confused with the containers service below there. The Azure Container Instance lets you create a instance of a container with just a single line. So basically the middle line that I have in here, AZ container create, resource group, the name, name of my container, pull down the image, what size of a CPU, how many CPUs, what size of memory, do I want an external IP address, what port is it exposed to, and bam. I can run that matter of maybe 10 seconds or so. I get a new container running for me. And that's actually something that you can all try yourself and see how many typos can you make in one line. It's actually quite easy to get started on that. Quite costly, so I won't run my production workloads in there, but I can actually plug my kube masters actually to deploy my application in a Azure Container Instance. So instead of deploying to a huge Kubernetes cluster that I have, for some maybe test and development, maybe smoke tests, whatever, for some temporary scenarios, I can actually use the Azure Container Instances as my Kubernetes nodes. Interesting. That's the serverless part of the Kubernetes that Lucas talks about. And the project related to that is nowadays called the Virtual Kubelet Let. They changed the name a couple of times. It was Open Service Broker for a while when they launched it at KubeCon. Then there is the Azure Container Registry, obviously for your private registry. That's a little bit better value for money. It's, I think, €5 a month or so with 10 gigs of private repository for your container images. And then there is this service called Azure Container Service. And with that, you can actually pick your own orchestrator, but what it is actually it's just pre-built templates, pre-built tools that lets you create a cluster of virtual machines and pre-configured orchestrators installed on those clusters. It's just an easy way to get started, but in the end it's just the template. You still do all of the managing yourself. Then there is another service called Azure Container Service. And I abbreviated here a little bit better. Actually it is Azure Container Service, apprentices, open apprentices, Kubernetes or preview or managed, depending on which day of the UI that you are looking at. But basically, if you look for Azure Kubernetes Service, that is abbreviated AKS, not Azure Container Service, ACS, then you should find this. And this is the more interesting one. This is the Kubernetes Masters as a service. This is the managed Kubernetes. That's now the maybe more cloud-like. This is now something different that I can't really do myself on my own servers. So in this case, if I take it the Azure Kubernetes service from Microsoft, from Azure, Microsoft takes care of managing the masters for us. So there was the etcd, all of the stuff that was on Lucas's architecture in one slide. All of the parts that were in the master part, that's taken care of by Microsoft. So it's all upstream, it's the actual open source Kubernetes. It's just Microsoft that goes in and updates them. It's just Microsoft that goes in and does the upgrades, high availability, healing, all of that. I don't actually get even billed. So even if I don't want somebody, even if I'm okay doing the upgrading myself, just the ability to kind of skip the cost of the masters in the cluster is actually quite attractive in there as well. And they're doing some pretty nice stuff with that. With that, let's try to jump into demo. And I usually use several hands in my demo. Now I have only one. So let's see how this goes. So bear with me. I might cheat a bit with some copy paste just to make this a little bit more interesting as well. So first of all, as you see, I'm in my Windows 10, but I am using Windows subsystem for Linux. So this is actually Ubuntu on Windows 10. Interesting. I have some stuff here. You actually see this bit. I might do a little bit of zooming in here as well. So this is basically, this is not virtualization, this is actually running inside my Windows in here. So I'm not doing Windows containers. I have Docker for Windows installed, but I'm not doing Windows container demos here. This is actual containers. And let's zoom in a little bit. Is this okay? Can you see this, guys, in the back? Sure you can. Okay. So first, quickly, I'm going to show you that I'm logged in my Azure account, if I haven't been timed out. Let's cheat again. What did I typo? Yes, there we go. So I'm logged in. I'm in my Azure cloud environment. It's the name of my account. This is what I use to log in. And this is basically the same stuff that I get if I just go to the Azure portal and log in here. So this is all the same accounts. So I can go and see what resource groups do I have. Let's just use the history. It's a little easier this way. I'm going to show you the stuff that you can see on the portal as well. So this is all the stuff that I can get with anywhere that I have a command line. You can get the tooling. It's basically just to install the AZ CLI, and once you have the packages installed, you can use this with anywhere. You can use it on your Mac. You can use it with your Ubuntu or whatever suits your tickles your pickle, so to say. I can even, for some reason, I can even install this on my Windows, actual Windows as well. So here I'm using it on my Linux environment, but I can install it on my Windows as well. So let's get started with our first demo, because this is actually going to take a while. So I'm just going to steal this as a copy paste here, because even writing the five characters was too much for me. So what I'm doing here is the simple command line query, AZ, Azure Container Service, AKS, create obviously, group, we give it the resource group name, the subscription, the accounts, all of that has been taken care of before I logged in. Then I give it the name of the actual Kubernetes cluster. Then I give it the amount of nodes, in this case 1. Then I can type down the version. This is the specific version that I want here. I can go with the default as well. And then I select the size of the virtual machines that are given to me on this installation. So this is something that if I know already what I'm doing, I pick the right size. This is the scaling up or down, or scaling vertically. This is something that I cannot change later on. I can later on scale the amount of nodes, but this is something that I cannot do. And I'll just let it create me some SSH keys as it goes as well. And I still made a typo, however possible that is. Yes. Okay. So now it's getting started in there, so we can go actually to the UI and see what is actually happening in here. So in my resource groups, as you saw when I clicked refresh here appeared a new resource called whatever I typed a name here. It's still creating, so I get this sad crying little cloud in here. So it's going to take a while. It's somewhere between 5 to 15 minutes, but luckily I had this already created previously, so we can look at the previous one here as well. It's the same stuff that I actually typed in on my creation. here's my Kubernetes version, here's the specific node size, here I can scale it up and down, I can do it here on the portal, I can say that yes, please give me actually 2 nodes instead of 1, and I can do it here as well. What else? Once it is actually deployed, I can actually get the credentials. So I've actually gotten those already for the O2 cluster in here. So once I have done that, they're actually added to my kubeconfig. So once I've done that, I can actually go ahead and browse to the, if I want to, I can browse to the Kubernetes dashboard there as well. Let's create a new bash on Ubuntu on Windows, very meta topic. And let's run not the O3 because it shouldn't be up yet, but the O2 because it's already there. Okay, so now it's opening me a SSH proxy, SSH tunnel, and opening up my browser in there. And it is apparently handling the connection for me. However, handy dandy. Let's see what's happening. Let's try this again. Number 2. This is the fanless design that you hear, everybody. So opening up a Firefox is too much for my i7 laptop. So we can go to backup slides if you want to. But anyway, it will open the.
Just go to the Firefox and open
nope. Because my Firefox is installed in Windows. The tunnel is actually opened in the Linux side, so I actually have an X server that I am remoting to, or I should be able to remote to, but in this case, no. As they say on the native side, it worked on my machine. I do have a picture, but I don't think that's helpful for you. So what's going to happen, or what should have happened in this case, is that it should have actually popped up my Firefox from my Linux side and doing that as well. So we can actually see that this is still creating here. So we can actually see if we can actually close the wait and see if we can actually do it here. Just this one once again, and if not, then it just doesn't help us. There we go. And now I started my Linux Firefox from my Windows subsystem for Linux, and which was not the point of the demo. The point of the demo was to show me the Kubernetes dashboard that's running on my managed Kubernetes on my Azure. And there it is. It's a UI. Yay. There it is. We can actually get back to that as well. We see that the cluster is actually spinning up. It's still on the creating side. Oh, yes. The reason I wasn't able to open that one was, of course, that I was actually in the middle of my scaling operation that I showed you and put in place on my UI. Very good thing to do some unprepped demos in there. All right, it's going to spin up. We can do some stuff. We can deploy a service in there. What given that typing is very hard for me, you can try it out yourself. Basically what you do is you pay for the amount of nodes that you use. Currently there are not very many different sizes of VMs available for Western Europe, which is the one that I typically use. So just go with the smallest ones, they are pretty nice. This is what we did. You can get those on the meetup as well. The get credentials is the part that actually fetches merges those with my local kube config. We use the browse. I didn't show you the scale. I showed that on the portal. It's very similar. You can look up the docs. I can do some upgrades, and that is actually something that I can show you. No. Only my shittiest cluster is up and running. So this is also something that I can leave to you as a homework. So you can actually go ahead and use the AKS upgrade command to actually upgrade. I think the latest one is the 1.8 series. So within the major versions, it actually updates itself. But from different versions, you actually have to go and perform the upgrade manually yourself. Currently it is still in preview, so the 1.9 is not actually available here on the managed Kubernetes side. I still had to build my own using the other Azure Container Service for that. I use the AZ CLI. That's a tool that you can install yourself. I can actually also use shell.azure.com. Which Firefox is it? It's this one. So it's just literally shell.azure.com. It's the cloud shell for Azure. It uses the same credentials. The beauty of it is actually that everything is installed for me, so I don't have to worry about the different versions of Linux or Windows subsystems for Linux that I run. This always has the latest tools, so this is the easiest one to get started. What else did I want to show you? Visual Studio Code, also a great tool for creating your service deployments. There's a great set of extensions available if you want to be brave enough and actually work on your own YAML files. I actually use some other tooling, so the platform on top of platform. I use Helm charts for that. And actually when I do my development myself, I actually use Draft to actually create both of those, so both the containment and the service deployment as well. But VS Code is actually pretty neat nowadays, and all of those, both the AZ CLI, the shell, Cloud Shell, and actually the VS Code, they are actually open source as well. Funny thing, the shell.azure.com, this is actually also running inside a container as well, inside the Azure container instance. And that's why actually when it told me that it's getting reconnected, they actually didn't connect me to the same environment. It actually had killed already the container that I was in and created me a new one and mapped my persistent storage in there as well. All right, I'm almost out of time. You can go ahead and see all of the differences between Azure Container Service, Azure Container Service Engine, and Azure Managed Container Service up at GitHub. If you want to build environment yourself, customize it, you can use you should use the Azure Container Service Engine, ACSE, which is basically just a Go script that creates YAMLs and ARM templates that create the underlying Azure infrastructure for you. All of the commands that I showed you, the documentation, are up at docs.microsoft.com. The plugins, the Kubernetes plugins for the Azure Container Instance are up there as well. And there's actually a great recording at the KubeCon last year where both Brandon and Gabe actually talk about both their past, why are they at Microsoft, why haven't they left yet, and what are they going to do for the rest of the community later on as well. So it's a pretty interesting podcast, maybe like 20 minutes or so, and it's actually even transcribed, so it's 5 minutes to read as well. With that, I have 1 minute. I'm end of my slides. We can go and see if something's happening with my cluster in there as well, but I'm actually very happy to take some questions as well. Yes?
Why were you using kubectl on a Linux container inside Windows?
So actually, I wasn't using Windows. So I'm using here the Windows subsystem for Linux. So this is actually native Ubuntu running natively within my Windows, quote unquote. It's not virtualized. I'm not inside a container or anything. Why is another question. Anything else? Awesome. Then I think there's plenty of more beer left, and then we have the last session, and then the free-form Q&A. Perfect. Thank you.
Okay.
Yeah, there is still something to drink, so please help yourself, and we'll start soon with this.
Tämä on vielä hyvää kreiviä. Hyvä vuosikerta. En tiedä mitä tapahtuu, varmaan kaikki ole. Ei, kyllä vaan tulee takaisin. Tämä vaan ottaa se takaisin, kun se on äällä. Ei, no joo, joskus ehkä tulee vielä. Ei ainakaan tehdä sisäistä Mac-generaatiossa. Se on vähän huono. Näissä.
We don't need those streaming guys. Okay, yeah, so one more time, welcome here, and thank you, Lucas, and I already lost his name. Carl. Okay, yeah, well, it was Carl, probably. Okay, I was thinking about showing you some demo, but then you know what happens when you have to get something done very, very fast. Well, it doesn't, and so today we don't have the full demo. One issue is also because we are using that current version, we've been developing it with the customer. So we don't have the rights yet to open source it. We are still having negotiations, but when we get the rights, then you will get some free software. So today I will tell you about some CRDs and in action. So how to use Kubernetes as state storage for your extensions. And now you don't how many you know already what is the CRD? Because it will really. Oh, that's good because actually Lucas wrote what's the real meaning, like, because it's abbreviation, and I said that no don't you will waste my joke because I have few things like if you okay, well, it's not even funny now when I say it, it's not funny at all. But really, if you write CRD into the Google or something, you will find what it is. It's at least one disease, but I found some other thing. So yeah, I'm Teemu, and I come from a company called Emplica. I always say that we are a hard tech company, so because we are not doing JavaScript front end. But I don't say that's not hard. It's usually very, very hard to fiddle one button on the right place. So whoever you are doing that, I feel your pain. We're super small, though. Last time when I was presenting in this Kubernetes meetup, we were 5. Now we're 8, so it's pretty good. Actually, there is 2, Johanna and Robert. Show your hands here from us. So actually, both of them are kind of new, so it's it's good. We're still hiring, though. So we've been doing with some Finnish clients mostly, some startups and some bigger enterprises too. We're doing some big data stuff, something related to IoT thingies, something related to video, and something related to new fancy machine learning stuff. However, now I'm going to explain what is the CRD. So it's math. It's just this one function, and no, it's not short function. Though Wikipedia says it's actually a long word, and it means custom resource definition. So it's a Kubernetes feature to provide custom APIs, custom REST APIs for you, and it has a few features on it. So it's not just some custom API, but it's something that you can define. Actually, even pretty strict way. So that way you can have your data consistent and most of the Kubernetes tools that are actually automatically generated from the Kubernetes API manifests can use them straight away. So you can create API that you can use with the tools that are already available, such as your kubectl tool. This is how it looks like. So this one is the custom resource definition. So this defines what kind your API will be. And here is, as you can see, it's actually lots of things about naming. So there is, for example, now I'm creating some new called cron tabs. And I'm just telling the Kubernetes what is the namespace, what is the version. I'm telling that how I should call it at the APIs or somewhere else at the tools. Then when I push it, I can have that kind of API. Well, that's sad. There is a line. Okay. Well, even though it's URL. Oh, okay. Well, that's good. Well, yeah. So after that, you can access it even with your web browser. It works like normal JSON REST API, but it comes from the Kubernetes API. So then I can create REST objects, even with kubectl, because kubectl works straight away with the CRDs. Lucas looks like, huh? Am I saying something not right? Okay, cool. Yeah, I was really worried. Okay, so after that you can use your kubectl and some other libraries that are accessing the Kubernetes API. So all the API clients that are fully compatible with Kubernetes, they work straight away with that. And then you can get your objects on, you can list, or you can even filter them in some way. So it's essentially well, some kind of validated key value store inside of Kubernetes. And yeah, you can query like what is in of that and get its YAML presentation or JSON representation. And
yeah,
that's...
You can define define your own schema as well.
Yeah, you can define your own schema, yeah. And that's the little bit validation, because there is not a lot options, but it's JSON schema, so it's still possible. Well, that's so cool, because now I can actually, I don't need database, I can use Kubernetes for that. So everybody of you who've been always thinking like, what kind of database to use for my blog, use Kubernetes. Or no. Actually, there is a list like when to use it or when to create a new API. And because of this slide, I think I will need to make new pull request for one additional line. So if you're making a blog, please prefer standalone API. And if your custom resource really is related to Kubernetes or related for managing the cluster resources, then it's probably okay for using that. So what we did with that? Well, let's go forward. We'll see. So this is one of our customer projects. It's a little bit simplified version, and it's a little bit out of context, but it works. So we will have, let's say, only 2 systems, but in reality we will have more systems. And those systems will get, for example, hourly dumps of something very important data. And we want to have Kubernetes jobs running on top of that. Oh, other people couldn't see my slides. Robert, slide it left or right. No, like slide it on the right. Like, yeah, now it works. No, still keep it there. Okay, that's good. My bad. Sorry, internet. Well, I will scroll it through after this, so you will have some chance. Okay, so you will have hourly dumps, and we want to run some pods, some jobs, on top of the Kubernetes to actually process them. And there are some jobs that depends on other jobs. And this is something that you currently can't do with Kubernetes on its own. So you can't set some jobs that some job is depending on some other job or to finish it. So, of course, then you need to build something. In the open source world, there is actually already workflow managers for the big data stuff and all that kind of stuff. For example, Azkaban or Airflow is pretty good alternatives for that. But the problem with those are that they're not invented in the time of Kubernetes. So they're defaulting that you don't have any infrastructure for scheduling your jobs or running them on different machines, nor they support Docker containers usually. For the Airflow, there will be support in some point for Docker containers, but that doesn't still mean that we can run on stuff on Kubernetes. I saw a few pull requests for a few GitHub issues regarding that, but it was not ready yet, and we would like to have it now. So the problem with the job scheduling, like on the order, is that we have to solve directed acyclic graph. So we need to know the order of when we run each task, so we can have them like so that if something needs. For example, we have one here, let's say, here we go. So if we want to have the ML model trained, we need to have a whole data set. And those are different pods. So these are different Kubernetes resources, and we need to get them first. So that's why we need to also calculate the order. And that's topological order of the directed acyclic graph. So oh, that's hard. Hard to say in English. Well, after that, we will get the order, and we can also see that what's depending on what. So we can probably even run some things in the same time simultaneously. And for the solver part, it's very easy, and the Kubernetes actually solves the scheduling issue. So there is not so much to implement for the full working workflow manager.
oh yeah, this was the last idea. Like, why not use Kubernetes then if we have the problem? So we created something. It's called Dagger, and it actually solves the problem that how we can use Kubernetes jobs to first easily move the state between those jobs and run them in the correct order. We are using the CRDs because they work as a database. We are using them to store the workflow manifests. So those manifests are actually defining what kind of tasks we have and in which order. Or actually, they don't decide which order they define what depends on what. Then we also use CRDs for storing the workflow state. So each time some job completes, the Dagger daemon itself will write to the CRD that now this task is done, and we can continue calculating what's next. Also, if something fails, then it can force to retry. But actually, it works pretty good way with just Kubernetes jobs. They have some kind of error management too. And then, well, for the Dagger, so for your own application, if you want to build something on top of this CRDs, you just need to take care of the data coming. And for the Kubernetes CRD, it offers you the watchers. So you can watch some resource, and when it updates, it can react immediately. So you don't need to poll the API. Though we first started with polling, of course, because watching is too complicated for the starters. Now it's still polling. Okay, so it watches the jobs and updates the workflow state accordingly for that. This is how it looks like, and now I don't know if you can really see it, but this is how the manifest looks like. So this is pretty random manifest because there is some parts that are actually working and some parts that are not. But the very important part is the tasks. So here we have tasks, for example, load Kubernetes homepage that actually just runs in some busybox, some vget, and it gets the Kubernetes IO index HTML. And then after that, it will touch some file. So our Dagger will have also some sidekick containers watching the state. So actually, what happens inside of the Dagger container, there will be 3 images: one for the work, one for the state loader, so it will load some previous state if there is any, or some parameters to use in the actual work container. And after that, we have state saver container that actually takes the state and pushes it back to the object storage so it can be used in next stage. So the only requirement for the work container is that it will in some point touch some file. And I hope in the future we will have good support for a Kubernetes API to actually support the case that some container will get done or will get shut down successfully, so we can see that without the state file. So what happens here is that this one, which is very stupid name also, well, okay. Well, this one depends on the load Kubernetes homepage. So it doesn't run before the Kubernetes homepage is actually loaded. And if it fails, then it still waits for it to get through before it continues. And after it's ready, it will also touch the state ready command, the file. And then when we have the workflow, the only thing we need is to actually launch the workflow. And we use another CRD for that. Its name is Dagger Run. And this can be launched just with the kubectl tool. So we have here, for example, some input parameters we would like to input for the workflow. Or then we actually implemented some webhook endpoint, so you can ping on some webhook endpoint and it will automatically create this resource for launching the job. And this little resource actually changes after you submit it.
the Dagger will continue to updating this resource and update the state of the workflow here. So now we don't have, but we could have some fancy UI for seeing how it's going. So here's one more time. User can create a Dagger manifest and launch it multiple times with the Dagger run. And after that, the Dagger itself will see the changes in Dagger manifests and Dagger runs, and it will create jobs accordingly for those. We're open sourcing Dagger soon when we can, so wait for it. Okay, thank you. If you have any questions, please. Oh, somebody's going to applaud. Okay. Yeah, so any questions about CRDs or Dagger or anything? Okay.
Any estimation on the date of the open source?
Okay, that means you're interested. No, not yet, not yet. I think in a few weeks, in a couple of weeks, but I'm not sure yet. Like the open sourcing, it is pretty much the second objective. So, but it's actually running already, so it's some kind ready. But probably the code, there is some. For example, first we started it with just Kubernetes kubectl. So we actually from our code we just used the kubectl straight away. So we didn't have any API library, because that's actually very easy when you output just JSON. So we need to replace those before we open source to use the real library. And also what I would like that it would automatically, like I don't want to just implement new client on top of the REST APIs, but I want it to actually automatically discover the versions of the API. Then some more fault tolerance is actually needed before the launch. But yep, it won't be ready in that that mean when we launch it. So it's if somebody is interested in contributing in that, good to hear. Anything else? Okay, I have one more thing for you. Actually, it's not related for Kubernetes anyway, but it's related for what we do. One very stupid thing we do is push-ups. So do sports and use some machine learning to count them. Thank you. It knows them. It's generalized to this point.
So any front-end developers? No.
Okay, here we go. You get to do something.
Oh, I don't know.
So that's it for today. I hope you enjoyed the talks, and this last one is a good example of what you can do with Kubernetes, and Kubernetes is meant to be built upon for exactly these things. Okay, the core job object doesn't support this feature. Well, then we write a couple of lines of code to make that work with a custom resource definition, for example. So now we have, as I said, an hour or so to just discuss or well, hang out in a group, whatever, and then we have to.
Yeah, I think that sounds like a plan. So please, well, there is not lots of things to eat, but at least there is something to drink. So drink and have a conversations with each other. Thank you.
Yeah, and there's a swag table, so you can grab some stickers or t-shirts.
Yeah. So anyone can, for future meetups as well, anyone can bring swag in any form and to such a table and exchange whatever you like. Cool. Thank you.